Hello, everyone, and welcome to today's webcast on Tableau with Python and R. So, quick introductions. My name is Brendan Lundquist, and I'm joined by my colleague, Scott Stieritz. We are both business intelligence and analytics consultants at Thorogood, and we both work out of Thorogood's Philadelphia office. So, quick intro, quick agenda here. So I'm just going to give you guys a quick introduction to Thorogood before we get into the webcast content. We are an independent professional services consulting firm specializing in business intelligence and analytics solutions. We operate as a single organization serving our customers globally with leveraged teams of consultants in our offices in New York, Philadelphia, and Sao Paulo in the Americas region, additionally with offices in London, Bangalore, and Singapore. All of our consultants are recruited and trained in the same way to develop a unique mix of skills, blending business understanding, technical aptitude, and a deep understanding of analytical tools and techniques. We offer a full range of services from BI strategy and roadmaps, architectural recommendations and design, solution design, end-to-end implementation and data services, and support for product applications. We also support our customers in user training and empowerment programs, which we're seeing a whole lot these days, particularly with organizations looking to adopt the self-service culture. In terms of the technologies we work with, we are an independent consulting firm, meaning we don't work with one specific technology. We do, however, work and partner with many of the key players in the market in order to provide our clients with a solution that best suits their needs. We have quite a bit of experience working across a number of front-end reporting advanced analytics tools like Tableau, including with Python and R. And we also work with numerous technologies within the industry that really allow us to use appropriate tools to the best effect possible, depending on whichever situation is presented. So these are just sort of our Tableau credentials. Thorogood is an alliance partner with Tableau. We're a member of their partner advocacy board, and we have 85+ consultants experience with Tableau development and delivery. So now to get into today's content. So a quick introduction to Tableau. I'm sure that many of you that are tuning into this webcast have some sort of familiarity with the product, but for those of you that don't, let me quickly explain to you the suite of products that Tableau can offer and what that can do for your business. Tableau development really starts with Tableau Desktop, which is the program that sits on your computer to allow you to connect to and visualize your data. And this is where you can create your dashboards to rapidly explore, analyze, and visualize your data. Ask Data and Explain Data are relatively new features in Tableau and offer users greater self-service capabilities. Ask Data is a natural language query processing tool, and Explain Data leverages AI to explain a specific point or multiple points of data. From there, you want to distribute your created report, which is where Tableau Server comes in. It's a web-based platform viewable within your web browser, like Internet Explorer or Chrome, where multiple Tableau workbooks can be published within and shared with hundreds or even thousands of users to enable enterprise collaboration. Additionally, from an enterprise governance perspective, you can have IT-supported data sources published on Server, allowing users to leverage those data sources for their own analysis. There's also Tableau Online. Tableau Online is essentially the same as Tableau Server from a user interface perspective. You're still allowing your users to access published reports and data sources within their browser. However, the only difference between Server and Online is its underlying infrastructure setup and service model. Tableau Online is hosted and maintained by Tableau themselves as a software as a service offering, which is available as a subscription, whereas Tableau Server is under your business's control. And lastly, we have Tableau Prep, which can be split up into two features that add up to one whole. Prep Builder allows you to connect to multiple data sources and customize their combination using filters, joins, and more so your data is exactly how you need it. And Prep Conductor allows you to publish the data flows that you made within Prep Builder manually and on a scheduled refresh schedule to Tableau Server and Tableau Online. So what can all these product offerings do for you and your business? They can offer powerful visualizations that offer your data in a dynamic and digestible way for all aspects of your business. They'll also allow you to access quick insights and unearth trends and correlations in a manner in which you may not have been able to see before. And lastly, the concept of self-service. Self-service puts the power of data analysis back into the hands of those that need to see the data. As with Tableau, I'm sure that many of you are familiar with both R and Python. They are both free, open-source languages with extensive programmability and are the leading tools used for data science applications. Since its inception in the early 90s, R has been used primarily by data scientists to construct complex models and derive value from data sets. Being that R has been around for nearly 3 decades, the packages that data scientists have developed and iterated upon have grown to provide valuable and robust tools in the realm of data and statistical analysis. Python, on the other hand, has the same programmability that R offers, but not as focused on statistical analysis as R. Python has specialized deep learning and machine learning libraries that lend itself to a different kind of data science application. Both work well in Tableau and both are great programmable languages. And when looking to incorporate one of the two into how you actually use Tableau, both function in the same way, and the selection of which language they utilize is dependent on whatever the user prefers. So now that we have a general understanding of Tableau, Python, and R, why would we want to combine them? Tableau has the ability for advanced analysis, but the ability to couple existing R or Python packages and pass it through Tableau and utilize Tableau's powerful visualizations lends itself to some powerful reporting and applications for business users. However, the traditional process for interaction amongst business users and data scientists has inherent flaws. Data scientists will spend time developing models and eventually deploying them to the business users in the form of some sort of extract. This inherently leads to business users utilizing these analytical tools in silos, where they spend time manipulating their own extracts in their own individual way to suit their business needs using methodologies that do not necessarily lend themselves to much collaboration. Each user will be having their own version of the model and their own individual analyses, but the lack of one source of truth that they always come back to leads to disorganization and general confusion over what's what. With Tableau, you can swap out these workbooks that are being provided to business users and replace it with something that your business may already be investing in, thus putting your analytical and reporting tools into one place. Combining Tableau with R or Python works in a similar way as traditional methodology. Data scientists will still be developing their models, but instead of deploying them in the form of extracts directly to users, they can publish them directly to Tableau. Because your business presumably has some sort of investment into Tableau as an enterprise solution, the models and analytical tools that have been developed can sit with and be integrated with the existing reports that your business users are already comfortable with. The analytical insights can even sit on top of and enhance your visuals that your business users are used to seeing for increased familiarity. And not only will they be placed to see the integration of their tools into one place within Tableau, but the nature in which Tableau integrates with R or Python allows for constant iteration of a model without largely impacting existing work, meaning your models and thus the analyses done by your business users better. And most importantly, by packaging Tableau and other analytical solutions into one place, it builds trust and value of business users with the tool and lends itself to a new level of self-service, and therefore greater insights can be discovered, helping you and your business. Okay, so now that we have an understanding on why you would combine Tableau and Python or R, let's get started on how Tableau and the languages actually work together. It starts first by utilizing these 4 functions that allow you to call R or Python models functions. So these 4 functions can return either a real number, a string, an integer, or a Boolean value. That's the only difference between them, the data type and value that is returned from the R or Python script that you specify. So the following screen grab details an example of density-based spatial clustering of applications with noise of Python integration with Tableau. Take a look at how the solution to the problem has been constructed within the calculated field. Note how it first specifies what kind of value will be returned as a result of the function that is being called in Python. This particular application of Python within Tableau returned a string value. The structure for real numbers, integers, or Boolean values would remain the same if your respective script you were running in Python required it. You then have the bulk of the Python script that can be written as it normally would be within some sort of Python environment. This is where being able to connect to an R or Python server is incredibly important, as this allows for all the values you specify within Tableau to be passed through there. And lastly, you have each argument that is passed through from Tableau that you want to be called within your Python script. Each argument that is called within the script has a corresponding value from Tableau, and the order in which these arguments are listed within the Python script matter. So you want to be able to align the order of latitude, longitude, distance between incidents, and incident count to arguments 1 through 4 within the script above. Note that just because this example is highlighted done within Python, the same 4 functions and the structure in which our script can be passed through Tableau is identical. All right, so you have your Python and R scripted out within Tableau in your calculated column, as you saw in your previous slide. Tableau isn't actually running these scripts within Tableau itself. It's passing those scripts through an external connection that you can set up within Tableau. For your own exploratory purposes, you can download an instance of R on your laptop and connect it with it that way. What essentially happens at this point is that Tableau is leveraging your instance of R to return values based on the script that you've written within your calculated column within Tableau. However, for a more enterprise-level solution, you can connect Tableau to a server that is running R or Python. This will do the same thing as just running the instance locally on your laptop by passing values and actually executing the code wherever you specify. More users will be able to connect to this external service and is much more conducive to scalability as your Tableau and corresponding analytical tools continue to grow. Lastly, all the values that have been passed through the external service will spit back to Tableau as table calculations into whichever visual you deem fit to present your results. So what exactly do I mean by table calculations? Well, table calculations are returned from the 4 different functions that I specified earlier that you must use in order to run Python or R within Tableau. A table calculation means that values are computed and stored locally in Tableau and are not processed within your actual database. This means that the calculations are only being done on data that already exists within Tableau and will not affect the underlying data that exists within whatever source your Tableau workbook is pulling from. Table calculations also only use whatever information is available within a visualization. It takes all the fields that are used to define said visualization and performs whichever calculation that you have specified. Essentially, a semantic calculation is applied to all the information that is present on the underlying table of data that is supplying the visual. There's definitely a limitation to these calculations because they are based on what is readily available within the visualization. The way in which that information needs to be saved is to either export it as a crosstab so that information can be stored in a manner so that it can be accessible later in, say, the form of a table. It's also important to note that your table calculations cannot be used as references. If you want to save your results from your R or Python analysis, you need to do so upstream in Tableau Prep. More on that later. Our first demo is going to look to show the value of doing some outlier analysis on some sales data and to look for a reason as to why these outliers could possibly be happening. So, why is this outlier analysis valuable? For the purposes of our first demo, we're going to examine the use of R and Tableau Desktop to create visuals that allow for the user to detect outliers in dollar sales across historical data points. The main users for this dashboard are promotional planners that are responsible for creating and scheduling promotions up to 2 years out for their portfolio of brands. These planners typically use historical promotional data to plan their future promotions. Typically, it's hard to nail down and quantify event success due to the large numbers of external factors that can affect a promotion that could be out of planners' hands. Think, for example, today with COVID-19 or a natural disaster or other competitor promotions. Still, they're always interested to understand if the dollar values around the promotional periods are changed in any way while promotions are in effect. Additionally, due to the nature of budgeting and requesting for funding, the promotional planners have to submit convincing requests to receive funding greater than $50,000 to run a future event. Therefore, data-driven analyses are the recommended method for convincing. The typical promotional planner doesn't have a wide array of data science or big data toolkits readily available, as their core job function focuses around the promotions. Integrating R scripts that allow them to see where the outliers are located can give them a valuable view without requiring any additional software licenses or other teams to get involved. They already use Tableau for the majority of their reporting and self-service analytics, so why not bring in R? Now for this particular demo, we'll see how the outlier detection for brand sales gives the planners areas where they can zoom in on some of the promotions that will run in that time frame. Note, oftentimes, simply finding the right historical promotions to model after can be a challenge, as there could be between anywhere from 50 to 80,000 promotions run every single year for a given company. Now a planner can go into the dashboard, select their brand of interest, and use this as an exploratory tool to hone in on which historical promotions could be used as templates to run future promotions. So without further ado, I'm going to bring on our first demo. First and foremost here, we have our dashboard with several different visuals, but I first want to show you how you would first connect to make sure you're connected to your instance of R, either on your local machine or you're connecting to a server. So right here, I'm connecting to my local machine. I have an instance of R on my laptop. I'm just going to test the connection and make sure everything's working appropriately. So I'm connected to my instance of R, so I can now run R using Tableau. So before we get into the actual dashboard, I want to sort of explain our methodologies and the reason and how easy it is to sort of incorporate an R script within Tableau. So as you can sort of see, this is one of the 4 functions that I called out earlier, and it is computing a table calculation. It's going to be returning a real value, and what this function and script will be doing within R is basically computing whether the sum of dollar sales over this weekly period is going to be classified as either an outlier value or a normal value. Now, it's pretty cool because this wasn't our first approach. We took, as we were sort of seeing all this data come in, we initially were just going to look at, our peak values to sort of see, okay, we're going to take our 5 highest peaks, and those are going to be classified as our outliers. And that's not necessarily the most robust analysis, but it is very easy to sort of change our approach and implement this new quick script, quickly update it without really breaking the model. So that just goes to show you the true integration that Tableau and R have to seamlessly be able to transition from one approach to another while still being able to apply the model. So here we go to our business case, right? So we're going to be looking at a couple of different brands and analyzing some outliers by using R. As you can sort of see here, we have a few different visuals. We have our line chart representing dollar sales over a weekly time period for about 3 years worth of data. We have a few different sliders that sort of can represent when our promotions start and when our promotions end for particular brands. And lastly, we have promotional data. We have, how our social media index, which is measuring our social media activity for a particular brand. And then we have, for each particular brand, the promo start and end date, as well as what the event was for a particular week or several weeks, depending on how long the promotion was running, for the brand that we have selected in the above screen. Say, for example, as I mentioned in the business case, I'm a promotional planner, and I sort of see, for brand 7, I've noticed that for August 2019, there's this really, it's a highest value for dollar sales in over 3 years, and I'm curious as to why that could possibly be the case. So I can look to see our promotional activity, and I can notice that, we ran this promotion, and as it turns out, the end date actually, corresponds with the start date of this steep rise in dollar sales over a 3-week period, ending on July 28th And, that's sort of, it could be a direct correlation. It could require further investigation. But as a promotional planner, I'm looking towards historical information to really see what I want to do for August 2020. So with that information, I can bring this analysis to my manager. I can say, hello, I'm looking for August 2020 to plan this possible promotion. And then you would go to the brand manager, same thing, say, hey, let's run the same promotion. Let's try to reach this $8 million sales number. Maybe we can eclipse it this year with this additional information. We can spice up the promotion a bit. But that's just kind of the analysis you can sort of see here with R by being able to identify these outliers and then sort of seeing, what sort of promotions will correlate it, right? So let's take a look at brand 5 as well. You can sort of see here it's just going to take a second to calculate, the information that's readily available for brand 5. And again, we sort of identify, 4 different outliers through the values that have been passed through this R script. And we can sort of see here for December 22nd, right, it's the same sort of deal. We have this promotion that ran up until the middle of December, and it coincides with this rise of sales for December 2019. So again, I'm going to go to the brand manager and I'm going to say, look, you ran this promotion last year. Let's do something similar for 2020 and eclipse that $19+ million sales value on here. So it's just a type of analysis where you may not generally be able to see within your just looking at it, but being able to leverage R, identify these outliers, identifying the normal patterns within a window of time, and then being able to utilize that further. And just a quick explanation onto how these values are sort of being passing through. So as I mentioned, visuals within Tableau are being powered based off of off these table calcs. So for brand 5, you'll remember that this value has been identified as an outlier. 20 million here and 19 million here for this December value. However, if I were to change this filter to brand 7, you will see that Tableau is going to have to recalculate it, and it's not storing brand 5's values. So you'll see these are now all brand 7's outlier values, and you'll remember the August 2019 $8 million value for brand 7 is here. So you can't store and reference those future outlier values to be leveraged for future analysis, and that's really the limitation of the table calcs within Tableau. So without further ado, I'm going to hand it over to Scott, where he's going to talk about how to leverage Tableau Prep to use some of those upstream calculations.
So as Brendan mentioned, there are some limitations with embedding all of our analytics in Python or R into table calculations in Tableau. So again, like Brendan said, one way that we may be able to approach some of these challenges is by pushing our analytical calculations upstream. So first, we'll start with a quick overview of using R and Python and Tableau Prep. Really the pattern for Tableau and the external R or Python connection was set a number of years ago by Tableau Desktop. So the fact that the products are integrated with those languages is really not all that surprising. But it actually is a pretty recent advancement just within the last year or so that R and Python can be integrated into Tableau Prep, specifically Tableau Prep Builder, which again allows us to integrate these types of transformations or analytical calculations into our data prep flows and really pass that calculation upstream rather than having them as table calcs. So if we think about this visually, from the kind of use case that Brendan shared, we start with our data. That data goes into a Tableau workbook, and then within that workbook, we're building out visuals that we can see on the screen. And then if we're interested to do so, we can take the data when it's formatted in a certain way and have that calculation be passed to a server. It could be local or it could be a remote server. It could be running Python or R. And do some calculations there, and then those results are passed directly, again, to a visual. So we can't really do anything with the results other than have them spit right back out to the visual that we're targeting. But if we think about integrating Tableau Prep into this as well, we can take our data, bring it into to our data flow with Tableau Prep, and then just as a step within that data flow, we can start kind of talking back and forth between Tableau Prep Builder and the Python or R server. So we can do some statistical analyses, we can do some custom transformations, and then we can take those outputs, and those outputs go into our Tableau workbook, which means that anything we would do in Tableau, building custom fields, using them as dimensions, building calculations on top of them, filtering on them, all that sort of stuff is now open to us. It's now unlocked for us by having the outputs actually be a part of the data model itself. So some of the key advantages, like I said, kind of the major one is referencing these analytical outputs in other calculations using them as dimensions, using them for filtering, but also the method for referencing the Python or R script is a little bit different. It's done by referencing external scripts, so like a .r or a .py file, depending on what language you're using, which makes, honestly, makes like continuous improvement from the data scientist side a lot easier. So, they don't have to go into your data flow and, update the script that's stored within the UI somewhere. They can just have access to the PY or to the R file and make updates to that as they go. And then, as long as it has the same inputs and outputs, if they're just making enhancements to their analytical approach, it'll kind of flow through seamlessly, I should say, into your data prep flow and into your outputs. And then lastly, we're passing processing time upstream into the data preparation phase. So if we had some really compute-intensive calculations that we're trying to run, it may take a little while for those to render on the screen if we have them as table calculations. Things might feel a little bit slow to the end user. So if we're computing them ahead of time, assuming we're computing them at the right level of granularity that we're interested to see, this can really reduce visual calculation and rendering times, making things feel a bit more responsive. So now we'll take a quick look at Tableau Prep Builder in action, working with these external connections. So as we think back to the user story that Brendan walked us through, we had sales and promotional data over time for our products at a consumer goods company. And then Brendan took us through bringing external connections to R or Python into a calculated field and identifying those outliers through a table calculation. But what if we want to not only identify the outlier data points, but also do some additional analysis on those outliers? If we think about the challenge that table calculations present, we can't take their outputs and reference them in further calculations. So as soon as we change the shape of the data sitting behind the visual, say, bringing on another dimension, something like that, the table calculation results change and we lose the identified outlier data points. So we can push these calculations upstream using Tableau Prep to help us with this. So I'll open Tableau Prep Builder here to show a pretty simple data flow where I'm connecting to that same source data. I have a cleansing step here so I can use some of the native transformations within Tableau Prep Builder, which can also help to streamline our analyses a little bit using some of these native transformations. Here I'm just doing a calculation on this time field, which was originally a text field that said something along the lines of like week commencing and then text of the date. So I can parse that text, pull out the date, and transform it into an actual date field in Tableau all in one step, which is pretty nice and pretty quick to work with. Doing a little bit of filtering, anything that I want to do here is kind of all possible. But then, where we're really focused here is on this script transformation. So this is where we can actually bring in the R or the Python script that we've created. So since I'm interested in doing that same outlier detection, I've grabbed what Brendan had in his calculated field, and I've just built upon it a little bit. So it works slightly differently here in that you don't, like I said, you don't put the script into the UI. You connect to a file. So here I'm already connected to RServe. It's an R server that's running locally on my machine, so that connection is already in place. And then I can just pick a file that has the script that I want to run. So if I take a quick look at the file, I've defined this new function called detect outliers. It does a little bit of data transformation, kind of some custom transformations that I already had built out in R, but I could integrate these into Tableau Prep if I wanted. And then it goes through at the level of granularity of brand and date and identifies the same outliers that we were looking at in Brendan's workbook just a few minutes ago. Then lastly, I have this function, get output schema, that's really just defining what the schema is. So it's letting Tableau know, hey, this is the data that you're going to get back. These are the columns. These are the data types of those columns, really, so Tableau knows what to expect. So if I go back to Tableau Prep, I have my connection set up. I can bring in the actual file, and then it just asks you to tell Tableau Prep which function you want to use. So I said I created detect outliers, and I just type in the function name, and then as soon as I kind of refresh that transformation there, we can see that it's calculating this new field called outlier. So most of them are 0, which is no outlier, but if I scroll down kind of far enough, we'll see a couple ones pop up as some outliers that this thing has determined. are unusual based on kind of the pattern of movement ahead of and following these data points in time. Lastly, I'm just outputting to a flat file so I can incorporate my results back into that same workbook. So, looking back at the workbook that Brendan was showing, we had, looking at the outliers, which were originally table calculations. I've updated these to just be pulling the actual data from the data model, since outlier is now a field, not a calculated field within our data model. So it's interesting here. It doesn't look that much different, but where things really start to look different is if I go to a new screen where maybe I want to do some analysis on the outliers themselves. So now I can sum them up by brand. So maybe I'm looking at this and think, oh, brand 10 has a lot of outliers. I can click on that, I can filter on that, and I can see all of those outlying data points kind of over time here. And I think, this is looking a little volatile, a lot of spikes, a lot of outliers. Maybe there's something about brand 10 that I want to look at in more detail. Or maybe when I kind of sum them by month and abstract it from brand. So again, another thing that I can do now that I have it as a data point within my data model, maybe I'll look at this and think, oh, there's a handful in July, there's even more in August of 2018. Then it kind of dies out as far as any unusual data points for a little while. And then all of a sudden we hit June, July, and August, and there's some more outliers. So, maybe there's something going on in these summer months where our sales are a little bit more volatile, or, they're behaving a little bit more unusually. So maybe I want to take a look at a specific time of year, something like that, to look into in more detail. So as I pull these slides back up here, so that's a pretty quick look at how Python and R can be integrated in Tableau Prep. Doing Python is identical if you want to bring it in there. It's just uploading a .py file instead of a .r file. So again, there's kind of a nice abstraction there. You don't need to know one language or the other. Whichever you're more comfortable with, you can do the transformation in that language. You can even have different transformations. Like you could have a Python transformation immediately followed by an R transformation within the same flow. So finally, some kind of some key considerations that we think people should keep in mind as they look to potentially get started with integrating Tableau and Python and R. One main one is solution architecture. So clearly there are a couple different options for how we can integrate advanced analytics or data transformation scripts in Python and R into our Tableau analyses. And depending on your organization's data architecture, you also may have kind of an API model hosting focused architecture, or you may think about pushing it even farther upstream these calculations. So we have a bunch of options. We want to make sure that we're balancing the advantages and disadvantages of each of these approaches appropriately when we're thinking about how this best can be integrated. We also want to think about modeling. So clearly this really helps with accessibility of analytical solutions. This integration between Tableau and Python and R means we can pretty quickly take some interesting statistical analyses and bake them right into some end visuals that users can interact with. But this doesn't mean that we should put any less focus on having robust, statistically sound analytical models. And it's probably even more important to make sure that we're using and understanding the models and the outputs of those models in the right way within these solutions, especially when we're taking these types of calculations and kind of opening them up to end users for ad hoc analyses. Then the last point I kind of wanted to mention is iteration and improvement. So one of the big value drivers here with Tableau's integration with R and Python is the ability to experiment quickly. So it allows us to rapidly measure business appetite for and value from these types of solutions. But we want to continually reassess this appetite, and we want to reassess this value as we think about future enhancements to our transformations and to our analytical scoring algorithms. We want these to be in lockstep with business need. And all of these areas, thinking on solution architecture, help with defining models, thinking about like iteration or streamlining or improvement of analytical processes are all things that we have quite a bit of experience with. So if these are areas in which you're struggling, feel free to reach out. So that's what we have for you today. Thank you very much for joining. As Brendan mentioned, we've put our contact details back up on the screen here. So feel free to reach out to us if you have any questions or want to chat about this or any of this stuff. But again, thank you all very much for joining, and have a nice day.